Hi, this lecture of the series how to find the inverse of Laplace transform. In front of us here there's an example y of s is equal to 2 times 2s plus 1 and the denominator is equal s cubed plus 3s squared plus 7s plus 5. As usual, the first step you got to find the roots of the denominator d of s. Make it here d of s equal to 0 and find the roots of this equation. We'll find that we have three roots, one at minus 1 plus j2, minus 1 minus j2. So the denominator can be expressed in this way. You say s minus the first root, which is minus 1, so s plus 1 times s minus 1 plus j, so be s plus 1 minus j2, and third one s plus 1 plus j2, so that will be equal to s plus 1. And how you deal with this one, I'm going to deal it in a different way. I will put s plus 1 in one bracket, and you have minus j2, s plus 1 in one bracket plus j2. And we know that when you have a plus jb times a minus jb, a times a is equal a square, minus j plus j will give positive 1 b square. So you just square this part and square 2 squared b 4, and that's what you have. So let's just do that. So d of s is equal to s1 plus 1, and you have a square, which is s1 plus square, plus b square, which is equal to 2 square. It means equal 4. So that's the way you're going to express the denominator of this function. So let's just write it ahead. So y of s is equal to 2 times 2s plus 1 over s plus 1 s plus 1 square plus 4. And always when you have complex roots expressed in this way, as we did here, then you use partial fraction. The first one is s plus 1. You have a constant k plus s plus 1 square plus 4. This denominator of order 2, so the top should be polynomial of order 1, like as plus b. So our task now is to find the value of k, a, and b. K is normal. We did it in the same way. You look at y of s here, this expression, you write it down without this factor s plus 1. Why? Because k, the factor of k is s plus 1. So you have 2s plus 1 over s plus 1 square plus 4. Substitute s is equal to negative 1, because s plus 1 equals 0, s equal negative 1. And find the value of k. We'll find that's equal to minus 1/2. So that's the first constant. How can find a and b? You get the common denominator, simplify the expression, then compare it with the numerator here. So let's do that. Y of s will be equal to s plus 1, s plus 1 square plus 4, and k multiplied by this one, which is minus 1/2, multiplied by s plus 1 square plus 4 plus a s plus b times s plus 1. And let's simplify the expression on the top here, the numerator. So n of s will be equal to, after simplifying, I did it. Is equal minus 0.5 plus a s square plus minus 1 plus a plus b s plus b minus 2.5. This is the numerator in the top here. The original numerator, we have 2 times 2s plus 1. So this should be equal to 2 times 2s plus 1. So it should be equal to 4s plus 1. All right. You compare, you'll find the coefficient of s squared is equal to 0 because you don't have s squared in the original expression. So write minus 0.5 plus a is equal to 0. And from this equation, you get the value of a is equal to 0.5. And you can compare, you have now the coefficient of s, you have the other coefficient here, the constant one. So you can do that, any one of these expressions. I will choose the easy one, b minus 2.5. That should be equal to, this is equal to, because you multiply, it should be equal to. So this should be equal to, accordingly, b will be equal to 4.5. We got a and we got b, and now we have the expression. This expression now is known. Let's just write it. So y of s is equal minus 1/2 1 over s plus 1, and the other one as 0.5 s, that is a, plus b 4.5. I'm just substituting in this expression here, as plus b on the top, and you have s plus 1 square plus 4. Then second step, you should find the inverse. Y of t, the inverse. So the first part is easy, because 1 over s plus 1 is equal to e power minus a, which is equal to 1, e minus t, ut, and the constant minus half, you have it here, minus half. So this part is done. The second one, I'm going to focus on it. 0.5 s plus 4.5 over s plus 1 square plus 4. That's the question. You look for the table, Laplace transformation table, see any expression which is close to this one. I found, of course, you look at the denominator, see, I mean, something similar. So I found the following. You can check the Laplace table that you have in the handout. E to the power minus at sine omega t ut gives omega over s plus alpha square plus omega square. And for the cosine, e minus at cosine omega t ut give s plus alpha square plus omega square. So this expression, it's kind of combination between, it has e minus at, and then like I mean, there's a constant times sine omega t, another constant, cosine omega t. So we don't know the combination or the value of this one, but we know it should be some expression like that, e minus at times sine and e minus at times cosine. The denominator the same, right? Both the same, and both equal to this one. So if you compare it, you will find s plus 1 square, that's the denominator of this expression, plus 4, that should be equal to this one, s plus alpha square plus omega square. Comparing that, you'll find alpha is equal 1 and 4 equal omega square. So omega equal 2. Well, no wonder. You could do that from the beginning because the roots, the complex root you found, minus 1 plus or minus j2. So when you have complex root like that, you know this is alpha and you know this is omega. So from the beginning, even before you make the comparison. Great. So what should you do next? So you know it's going to be E minus AT. So this alpha, the reason behind S plus alpha, it's just because you multiply by E minus AT. If you do not have the exponential multiply by each one, you should find the following. You should find, like, if only you have sine omega t, if you look at the table, you'll find it's equal omega over s squared plus omega squared. And if you look only for the cosine, you will have s over s squared plus omega squared. So the reason behind s plus alpha, it is just because of this factor e to the minus alpha t, the exponential multiply. All right, so what should you do next? Well, I want to make it an easy way to find these things. So I have the value here, 0.5s plus 4.5. 0.5s plus 4.5 over s plus 1 square plus 4. I have a nice trick that can make it simple. Let's call, s dash, new s is equal s plus 1. So this bracket s plus 1 just called s dash. So you know where is the sine and the cosine. Well, if you do that, s dash is equal s plus 1. So s dash is equal s plus 1. So s will be equal to s dash minus 1, right? Yeah. So I will go on this expression. I will substitute 0.5 and you have here s. I will put the equivalent s dash minus 1 plus 4.5 equal 0.5 s dash minus 0.5 plus 4.5 equal 0.5 s dash plus 4. So now the new expression in s dash is equal to 0.5 s dash plus 4 divided by s dash square plus 4. So you try to divide it into two terms in a way there is one sine, one cosine, because you know already the sine has omega square, and the cosine have s over s square plus omega. So this is the first part, s dash square plus 4. Let's just do it in this line bigger one because we want to do things here. S dash square plus 4, and another one, s dash square plus 4. So if you use s dash here and you put 0.5 outside, so this one like this one, like the cosine, all right? So this term will give you the cosine. About that, s dash square plus 4, you need to find 4 here. True? All right. So why I'm doing that? Oh, you have to have omega only 2. Well, that's okay. But you have 4 here. Simple. It's just you have 2 here and the other 2 outside here. 2 times 2 is over 4. Why I'm doing that? So it will look like the sine. So this one will give you cosine omega t, and omega is equal to, as you know, so 2t. And this one will give you sine 2t. And you have a constant here, 2. And you have a constant here, 0.5. Don't forget, s dash is equal to s plus 1 because we have shift. So now we add the shift, e minus t. You're done? Add. That's it. So the second part of y of t, you can write like that, e minus t as a common factor multiplied by 0.5 cosine 2t plus 2 sine 2t all ut. That's only the second part. And you have the first part with det. The first part, where is the first part? Yes, this one, minus half e minus tt. And the first part now, minus half e to the minus t ut. So when you add them, you get the final answer, yt. You want to make it look nice. Yt, you have e minus t common everywhere, so e minus t. And that's what we're going to have, minus 0.5, this part, plus 0.5 cosine 2t plus 2 sine 2t ut, and you are done. Okay, that's very important example, and I hope you got it.